Hi, my name is Catherine Cameron, and this is my Semester A project. My problem is predicting the population of California for any given year. The first thing you have to do is collect the data. The data shown are the averages for the data from the California Department of Finance, infoplease.com, Demographia, and negative population growth. The numbers in parentheses next to the years are the count of the years starting from 1850. The first method is to just look at the data table. If the value you're looking for is on the table, all you need to do is find the x or y value. For example, if you want to know the population of California in 1980, all you have to do is find 1980 on the data table and look at its corresponding population value. Here you can see that the data for the population in the year 1980 is 23,705,842.67. The second method is to use a scatter plot. It's kind of just like looking at the data table, except for in graph form, but an advantage is that you can really see the overall arc and the way that the line grows. Here's the scatter plot for our data. As you can see, as the x value increases, so does the y value. But as time goes on, the y value increases faster and faster. Here's an example. In 1950, you can see that the population is just over the 10 million mark. If you zoom in, you can get the exact value. The third method is to graph the function. The function is basically the best fit line for the scatterplot points you already plotted. Using your graphing calculator, you plot the data points. Then you go to Stat and then Calculate to find the best fit line. The catch is you have to know which type of line your graph represents. If you have a basic working knowledge of the 12 basic functions, you can tell by looking at the curve of the graph that this should be a logistic function. The calculator will tell us that for the equation, A, B, and C have the given values shown on the screen. All you have to do is plug them in. Here's the graph for the function. As you can see, it very closely follows the curve of the scatter plot. This is where those other numbers on the data table come in handy. Using the graph on the x-axis, 1850 equals 0, and the other values equal the year minus 1850, or the numbers in parentheses. For example, if you're trying to find the population in 2008, you take 2008 minus 1850, and you get 158. Using the traceability on your grapher, or just by looking at the graph, you can see that y equals 36877,840. So, the population in 2008 was approximately 37 million. Here you can see where that data falls on the graph. The fourth method, also my favorite method, is to just use the equation. If you want to solve for a population but you don't have access to a graphing calculator, or maybe you just don't like using them, or maybe you just really like algebra, you can just use the equation. Here you can see where we took the logistic function equation and put in the numbers that we got earlier. For example, if you want to predict the population in 2030, you subtract 1850 from 2030 and get 180. That's your x value. Then you substitute in and simplify. The simplified value is 42,237,831.14. So the population of California in 2030 will most likely equal that value. Thanks for watching this, and I hope you had a great time. Special thanks to the California Department of Finance, infoplease.com, Demographia, and negative population growth for all the amazing sources and data that I used to create this PowerPoint. Thank you.